Today I'm gonna show my second design of a generator coil. It is down here. It's a pretty smaller one. This piece of wood and the tape is just here to hold it in place. This coil doesn't need a transformer. It goes directly to the rectifier. I have here a 1.2 watt load and here a 5 watt automotive light bulb as load. The drive side is still the same. Starting the system up. By the way, this coil is also air core. I'll give the rotor a little bit of a spin. You can see air core. Okay, gonna start up with the first speed. This coil here behaves almost the same as the previous one, but this one, when it's shorted, it puts a lot of drag on the system. But when I put a real load on it, like a 1 watt or a 5 watt, it kind of works the same as the previous one. Going for second speed. The maximum speed of my rotor at this moment is 1100 RPM, same as in the previous video. The higher the RPM gets, the better the coil performance is. My previous video, that coil gets me the best results between 2500 and 3000 RPM. But this coil here, I calculated that I need between 9 and 12,000 RPM for it to do the same, and I don't like rotors that are running at such a high speed. So I'm building the next generation of that coil because I do like this one a lot. Going for third speed, which is overdrive. Gonna engage here the voltmeter. The coil is producing now 12.3 volts. I'm going now for the 500 milliamp scale. No load connected yet. Waiting for it to reach its stop RPM. It's getting there. Yeah, 18 volts at 525 milliamps is where it's leveled. It's almost there. Yeah, that's kind of about right. Okay, I'm gonna engage the 1 watt load. One watt DC load. Voltage is decreasing, which is normal. Let's say 9.9 for now, and milliamps is 275. Go to the front drive side. Milliamp is almost at 750 milliamps. Yeah, it is 750 milliamps. Volt output now is 9.7 at 75, maybe 60 milliamps. Test in the darkness. That 1 watt is pretty bright. Input volts, output volts, and light. Now I'm gonna connect the 5 watt load. Five watt is on. Voltage is 9.4 of 3, and the milliamps is 315, something like that. And at the front, the input amps is yeah, 775. Yeah, still climbing a little bit. Yeah, it's beginning to touch 800. So we'll just say 800 milliamps here. 9.2 volt output at 350 milliamps, 15. And here, yeah, let's say 800 milliamps. A test in the dark. The 5 watt is not bad. Now I'm gonna short that coil. I'm gonna use the other meter now, the 3 amp scale meter. Shorted amps is around 2, and you can see the input is way above 1 amp, and the shorted amps is 1.5, 1.6 maybe. I'm gonna unshort it because I don't want to damage this 1 amp meter here. Gonna put it back on the 5 watt load. The higher the RPM with this coil, the less drag it puts on the system when it's shorted and also when it's loaded. The loaded part comes at much lower RPM. The shorted part comes at a higher RPM, much higher. Because I've done plenty of tests with them, and each time I go for a few hundred RPM more, it gets better. Okay, this is the 5 watt load at 9 volt. Let me switch to the other meter. This one is difficult to see. 9.1 volt at 315 milliamps output. Input is 800 milliamps at 18.1 or 2 volt. Now I'm gonna put it on the 1.2 watt load, and I'm gonna shut down the complete system. Completely shut down. System is spinning, or I mean the rotor is spinning. No cogging effect, none whatsoever. 8.2 volt and decreasing. 230 milliamps and decreasing. Here's a test in the dark on it. That's the rotor spinning away. That's a good thing about air core coil. Just gotta love it. System still spinning away. In the next video, or the video after that one, I will be making a video on the high speed test with not this coil but the other one from the previous video. For this coil I need a ridiculous high RPM, which I don't like to do a test with. Thanks for watching.